I have had so many requests to cover sequences that I just couldn't resist. So without further ado, this is my sequences video. And for me, it's all about translation and also not being intimidated by those subscript numbers. What am I talking about? Well, let's take this question here. In a particular sequence, the term x subscript, that means like small and beneath the letter x, n, is given by that formula that you can see there. For all n is greater than 1. If x1 equals p, what is the value of x3? Many of you will be super intimidated by this point, going, wow, that is a bunch of gobbledygook, I have no idea what's going on. The first thing to recognize is that this is a sequences question because of those little letters and numbers that are beneath the normal layer of writing. So look at any of the x's, and then beneath it, you've got an n or an n minus 1. So we know we're dealing with sequences. That's step one. At least we know it's a sequences question. Okay, it's a sequences question, but how do we actually solve it? How do we make progress? First, we need to learn the translations. What does x subscript n even mean? Well, I've prepared the following translations that I want you to use. X subscript n, and by the way, the x could be any letter, K, A, as we'll see later, P, literally any letter. Xn translates as the current term. Just to be clear, that is not x times n. Even though I'm going to say xn, because I can't be bothered to say x subscript n every time, x subscript n does not mean x times n. The n is beneath the x, so we know we're dealing with sequences. Anyway, enough of that. That translates to the current term. X subscript n minus 1 is a simple language translation from maths into the words previous term. You can probably guess some of the others. Xn plus 1 translates to the next term. And this is decoding the language of sequences. Once we've decoded the language, the actual maths is lovely and fine and awesome. You just need to not be intimidated by those little symbols that are beneath. Just to be clear, for example, on the next one, x subscript n plus 2, that is not a normal plus 2. We don't add 2 to xn or something. No, we translate it. The plus 2 that you can see there with x subscript n plus 2 is translated as the term after the next term. Nothing to do with plus 2. Anything in subscript means we're dealing with sequences, not normal maths, so to speak. Anyway, x1 is the first term, x2 is the second term, and so on. And as I've said before, we can use other letters, A, P are common ones, K, for example. It doesn't have to be x. Okay, so far I think I've persuaded you that we're dealing with sequences because of the subscript, and that there are these translations that we have to use. And the subscript are not normal numbers, as I've written down below. But it still seems confusing, right? Let's apply these translations to the equation or the formula that they've given us in the question. By the way, let's just quickly unpack that question. In a particular sequence, the term xn is given by the formula. That's often the language they use, kind of introducing a sequence that they're going to use in the question. And then it says for all n is greater than 1. That's just a little disclaimer, meaning we're not dealing with negative numbers in this question. You don't really have to pay much attention to the n is greater than 1 in sequences questions. Without further ado, let's apply our amazing math translations. Okay, so in that formula, xn equals 3xn minus 1 plus 1. That means, using the translations we've got on the left, the current term is 3 times the previous term plus 1. Wow, it suddenly looks so much easier. Remember that n minus 1 is not a normal minus 1. We're not taking away 1 from anything. That just translates the xn minus 1 as the previous term. The plus 1, because it's in normal size, does mean plus 1, so we leave it as plus 1. Anyway, we have this wonderful and actually somewhat simple sequence. The current term in the sequence is just 3 times the previous term plus 1. we have our little code for making progress from one term to the next term. You times by 3 and add 1. To get from the previous term to the next term, times by 3 and add 1. Okay, what about this x1 equals p nonsense? Why are they using so many letters? Anyway, x1 translates, as we can see on the left, as the first term. So all they're saying is just pretend that the first term is p. Follow the sequence, and can you tell us what x3 is? In other words, can you tell us the third term? How much easier does this question sound once we know the sequence translations? And I encourage you to rewrite the question using these words instead of the symbols, just to help your brain out. The question is literally, if the first term in a sequence is p, and to get from any previous term to the current term, you multiply by 3 and add 1. That's how you make progress. Now please tell us what the third term is. Don't know about you, but that sounds a lot easier. Let's show you how that works. Well then, following the rule given in the formula, we multiply that by 3 and add 1 to get to the current term, the next term in the sequence. That would be x2. By the way, you can think of the previous term as the term we're on if you want, and the current term as the next term. Doesn't make any difference, it's just the next one in the sequence. Anyway, 3 times p plus 1 using the rule given in the formula gives us 3p plus 1. That is now our second term. If you want to, you can pause the video and therefore tell me what the third term would be. Well, as before, to get from the previous term to the next term, or the previous term to the current term, we just multiply by 3 and add 1. So we do that to the entirety of 3p plus 1 to get to the third term. So if the second term, x2, is 3p plus 1, we're going to multiply that entire thing in brackets by 3 and add 1. Bingo, 9p plus 3 plus 1, 9p plus 4. That is our third term. And we could keep applying the rule if we wanted, timing the whole thing by 3, adding 1, find the fourth term, fifth term, up to infinity. Once we've translated the sequence, the actual maths is usually really quite easy. Let's see if we can apply those exact same steps to a slightly harder example. If you didn't understand this example, you could rewatch it or try to understand in the next example. It's the same process we're going to use. We're going to translate the formula. Well, actually, step 1 would be we're going to notice it's a sequences question because of the little letters beneath the normal letters. That's the subscript. Step 2, we're going to translate. And step 3, we're going to apply the lovely little code they give us to get from one term to the next. Okay, just translate and solve, that said. In a particular sequence, the term kn, see we've used a different letter, k instead of x, doesn't make any difference, is given by the formula kn plus 1 subscript equals kn squared minus 1. There we have another code to translate for all n is greater than 1. If k4 equals 63, what is the value of k1? Now this question is slightly harder than the last one, because notice we have the fourth term and we need to work backwards to find the first term. But we're still going to apply the exact same principle. First, let's translate it. What does kn plus 1 translate as? You probably know already. And what does kn translate as? Well, there are the translations on the left. And applying those translations, kn plus 1 means the next term. And I would want you to write this out actually. Kn is the current term, and the minus 1 is just minus 1. Okay. Notice the minus 1 is in normal font, same size as the other k's, for example, so it doesn't mean previous term or anything. The little subscript is what we translate. Anyway, here's the code they're telling us. The next term in a sequence is simply the current term squared minus 1. Awesome. What about this k4 thing? K4 just means the fourth term. So the fourth term is 63. Now notice it won't be as simple as just putting the fourth term into the code, finding the fifth term, putting the fifth term into the code, finding the sixth term. There's a problem with doing that. And some of you who paused the video and tried it might have done that. The problem is you're finding the fifth term and the sixth term, where we want to go down and find the first term. Not a big problem though. All we have to do is apply the formula but looking to go down instead of up. In other words, let's pretend that the current term is K3 and therefore the next term would be K4. It's like we are rewinding the videotape. We're pretending we're currently on K3 and the next term along would be K4. Let's put that into an equation. K4, the next term, is the current term K3 squared minus 1. Don't be scared if you're thinking, I wouldn't have thought to do that. This is the same two steps you always do in a sequence question. You either move forwards by pretending that the current term is the current term and finding the next term, etc. Like you're on the fourth term and you want to find the fifth term and sixth term. Or you always pretend, if you're trying to go down, that the current term is the one below the one you've got. It's always the same two steps. You're either going forwards with the fourth, trying to find the fifth, or you're going backwards with the fourth by pretending that we're currently on the third. For example, if in this sequence we had the seventh term and we wanted to find the sixth term, I'd pretend that the current term is the sixth term and the next term after the sixth term is the seventh term. We can solve that little equation because we know K4 is 63 and we don't know K3, so we add 1 to both sides and square root. Of course, normally if 64 equals the third term squared, you'd get 8 and minus 8. Classic GMAT GRE trick. But here it did say that n was positive, so we know n is not going to end up, or even k here, k1 is not going to end up being a negative, so we can just treat k3 as 8. Now, if you are in doubt about your ability to solve this question, you now have an opportunity. Can you tell me what K2 is now that we know K3? If you want to, you can pause the video and this is your opportunity to shine. To work out K2, we're now going to pretend that K2 is the current term and the next term after it would be K3. Therefore, K3 becomes our next term, K2 is the current term, and we know K3 is 8, so we can just put it into the formula, solve it, and we get K2 is 3. Doing the same thing again, you can find K1 by pretending that the current term is K1 and the next term is K2, which we already know. Solving that, we get K1, the first term, is 2. If you're in any doubt about these two questions, I strongly encourage you to rewatch it because they sum up the two main activities you're doing in sequences, going forwards or going backwards. You can think of it as going up or going down. You're either at the fourth trying to find the fifth, or you're at the fourth trying to find the third. And the last two questions cover the two techniques you have to use. But notice the entire question seems a lot less intimidating when we translate it into words rather than this complicated subscript nonsense. Anyway, for those of you looking to really challenge yourself, I've added one final question involving a multi-layered sequence. Fairly tough, and it's going to combine two of the techniques we've used here today so far. Really tough kind of question, so don't be too off-put if you don't get it right. Either way, this is truly going to be a sequences extravaganza. Let us do it. In a particular sequence, the term an, different letter, doesn't matter, is given by the formula an equals an plus 1 plus 3 an minus 1 subscript plus 1 for all n is greater than 1. Wow, so many different translations we're going to have to do. If a1, the first term, is 5, and a3, the third term, is 1, what is the value of the fourth term? That's kind of freaky. They're telling us the first term, not the second term, and then they're telling us the third term. But they're not asking for the second term, they're asking for the fourth term. And we've got quite a long formula. If you want, I would recommend pausing the video, having a go, using some of the advice I've written below. Stay cool, just translate and insert, check you're going in the right direction, and a reminder that you can pretend any term in the sequence is the current one. Okay, let's do this one together. First, let's translate the formula using our translations that we know about. an is the current term, an plus 1 is the next term, and an subscript minus 1, or an minus 1, is the previous term, plus 1. So that's the translation, and we know that the first term is 5 and the third term is 1. But what can we find with this? That's what I've asked. And more importantly, what term shall we pretend is the current term? First thing, we clearly have 3 terms in a row, don't we? We've got the previous term, the current term, and the next term. Now, I'll show you a few different wrong things that we could do. We could call the current term the first term. That makes kind of logic, right? The current term is the first term, and then the next term would be the second term. So the current term, the first term, we would know. That's 5, that's the first term. The next term, A2, we wouldn't know. But then the previous term would be A0. Remember, if the current term is the first one, the previous term is the 0th term. But we don't know that. And we don't know the second term. So pretending that the current term is the first term won't really help. What's another wrong thing we could do? Another wrong thing would be to pretend that the current term is the third term. Why would that be wrong? Because we would know that the current term and the third term is 1. So that's the start. Problem is that the next term would be A4, which we don't know. And the previous term would be A2, which we don't know. That's 2 unknowns in one equation. We can't make progress. Instead, and you might be able to guess at this point, what shall we pretend is the current term? Let's pretend that we're on the second term. The second term is the current term. It's like we're going to fill in a hole. At the moment we have the first term and the third term. We're going to use this formula to fill in a hole and find the second term. Once we've got that, we can use the second term and the third term to find the fourth term. Anyway, if we pretend that the current term, AN, is the second term, the next term would be the third term, which we know, and the previous term would be the first term, which we also know. So that would be one equation with one unknown, which is A2 at the beginning, and we can actually work out what A2 is. How would that work? Well, if we pretend that the current term is A2, we just write A2 because we don't know what that is. The next term would be A3, and that is 1 because they told us in the question. And the previous term would be A1, and that is 5 because they told us in the question, giving us 1 plus 3 times 5 plus 1, which is 17. Okay, so we now know that the second term is 17. But the question was what the fourth term was, not what the second term was. So we're going to now pretend that our current term is the third term. Why? Because we know the third term, and if the third term is the current term, then the previous term will be the second term, which we now know is 17. The next term would be A4, which is the one we're looking for. We wouldn't pretend that the current term is A4, because then the next term would be A5, which we don't know either, so we wouldn't be able to solve it. Let's pretend, as I've written down below, we can pretend any term is the current one. Let's pretend A3 is the current term. Some students, if they like this approach, like to think of that as pretending that n equals 3, rather than using the words current term, next term. That also works. I just like the words, translating the maths into words just sits more nicely with me. So if the current term is A3, we get A3 equals A4 plus 3A2. In other words, the current term equals the next term, A4, plus 3 times the previous term, A2. We know what A2 is now, we just worked it out as 17, and the question told us what A3 is, so we can solve that to find A4. And we get minus 51 as A4. And that is indeed the correct answer. I thought I'd make this video a fairly condensed one, encapsulating all the necessary information for answering sequence questions on GRE and GMAT. Because it was so dense with amazing information and translations, you may feel the need to watch the video again or go straight online to practice more questions. Either way, with these translations and with the practice of going forwards and backwards in a sequence and pretending any particular term you want is the current term, you now have the tools to answer any sequences question that comes up in the GRE and the GMAT. Almost goes without saying, but of course do like and comment on the video if you made it this far. Thank you for watching.